This is a third and final video for section Seqr F. In this video we're continuing to look at geometric sequences, and in this case we're going to look at limiting sums for which the infinite geometric series formula can be used. So firstly, our example is a full water tank has a tap leaking at 1,000 drips per hour. As the tank empties, the leaking decreases by 1% per hour. The tap keeps dripping until the tank is empty. If each drip contains 5 ml of water, how much water does the tank hold? So let's think about what's happening. I have 1,000 drips to start with, and then it's going to decrease every hour by 1%. So if I'm decreasing by 1% every hour, I'm actually multiplying by times by 0.99, because you have that 100% minus 1% is 99%, which is a decimal is 0.99. Okay, so that is what essentially is happening, and that keeps going forever until the tank is empty. Okay, so my A1 is 1,000, my R is 0.99, and I want to find out what S infinity is, because I want to add up all the drips. So S infinity is A1 over 1 minus R. Plug in my information, I get 1,000 over 1 minus 0.99. Put that in your calculator and you get 100,000. Okay, so that's 100,000 drips. That's how many drips I have in total. The question says that each drip is 5 ml of water. So water is going to be my 100,000 times by my 5 ml, which is 500,000 milliliters or 500 litres. Okay, finish with a therefore statement. Therefore, tank holds 500 litres of water. Okay. Next we're going to look at recurring decimals. Now recurring decimals can be considered an infinite geometric series because they go on forever. Now we use the formula to calculate the sum of an infinite series to determine the fractional equivalent to any recurring decimal. Okay, you would have learnt if you did TM1 that a recurring decimal is a rational number. A rational number can be expressed as a fraction. So this is showing you how we can do that. So my first example here is 0.7 recurring. So that's just 0.7777. It keeps going. So I can rewrite that as 0.7 plus 0.07 plus 0.007 plus etc. Okay, so it's an infinite geometric series. My first term is 0.7 and my R is 0.1. If you can't see this, just go 0.07 divided by 0.7, so my second term divided by my first term to find out my R, and you'll get 0.1. So write out my formula, plug in my information. Now I want to keep these as decimals because I want to work out what the fraction is. So I get 0.7 over 0.9 times top and bottom by 10 to get rid of the decimals, and I get 7 over 9. So therefore 0.7 recurring is equivalent to 7 over 9. Our next example, 4.138, where the 3/8's recurring. So I can rewrite that as 4.1, so I write out what isn't recurring, plus 0.038, where that 0.38, that 3/8's recurring. Now I just think about the recurring part. So 0.038 recurring can be rewritten as 0.038 plus 0.00038 plus 0. You get the point. Okay, so it's an infinite geometric series. Okay, I'm identifying that, and you have that A1 is 0.038. Now R in this case is 0.01. Again, R is going to be 0.00038 divided by 0.038. So if you can't see what the R is, use your calculator to plug it in and work it out. Okay? So from there, write out my formula, plug in what I have. Again, I want to keep them as decimals. So I get 0.038 over 0.99. I need to get rid of the decimals, so that means I need to move this decimal point 3 spots to the left. So essentially what I'm doing is timesing the top and bottom by 1,000. And that'll give me 38 over 990. Now what you should do from there is check whether that can be reduced. Okay, so on your calculator you can do that if you want, and you'll find out it can't. It can't be simplified. Sorry, I've written that out wrong, haven't I? That should be 990. So I'm not going to worry about reducing it now. You would be working down your page. Let's join it together. We had 4.138 where the 38 was recurring. So that was the 4.1 plus 0.038. So we need to rewrite that as the 4.1 we can write as 41 over 10. Okay, and then we have plus 38 over my 990, which I just found out. I need a common denominator, which I keep writing 999, don't I? Sorry about that. So the common denominator is 990. So 10 into 990 to work out what you need to multiply is 99, and 99 times your 41 gives you 4059. So plus 38. 4059 plus 38 is 4097, all over 990. Now you should check on your calculator whether you can reduce it now. So just do the 4097 fraction button 990 and to see whether it reduces. But you leave it as an improper fraction. Okay, it can't be reduced, therefore 4.138 with 38 recurring is equivalent to 4097 over 990. Okay, what now? Practice. Exercise Seqr F3 of your textbook.